In this video, we are making this animated droplet generator. You will be able to control the animation and also have the wet marks as well as remove the smaller droplets that are on the path of the animated ones. There are many videos on how to make condensation, but most of them are not showing how to make them animated. So we will learn that today. You will need a bottle or a can that you can model yourself, or if you want to use this one, you can download it from the link in the description. You will also need a droplet geometry that is included in the file, or you can model it, which is very easy. It's just subdivided cube and you can use proportional editing to move the vertices around to get a few different ones, which then you will put in the separate collection. When you're ready, we can select the bottle and change this window to Geometry Node Editor and press New. First, I want to add the Join Geometry node. From here, we can add Distribute Point on Faces node and Instance on Points. In the Distribute Point node, we can change from random to Poisson disk, and I'll put 0.01 for the distance. Now, for the instances, we need to drag the drop collection in here. We can change position to relative and check separate children and reset children. And we need to check pick instances on the instance on point node. Now we can connect this to the instance here. We don't see anything yet. That's because we need to connect this into the join geometry. And now we have this big mess. First, we can connect the rotation to rotation, and we also need to fix the scale. We can add the random value node, and for now I will use 0.009 for the min and 0.01 for the max. Now it looks better, and we can increase the density until we're happy. That's okay for now, we can adjust this later. Okay, we don't really want the drops to appear on the bottom or the top of the bottle, so the way we're going to fix this is with the normal node. We will plug that into .product vector math node, and from there we will use absolute math node. We need also a map range node to control the contrast. If we plug this into the density factor, we have the opposite of what we want. So we need to invert the colors. We can just swap these two from 1 and to 0. And with these two, we can control the contrast. So in case you want some drops on the top or the bottom, you can control that with these two values. Okay, now we have small droplets. It's time to make slightly bigger ones. We can just duplicate this setup with Ctrl-Shift-D to keep the connection, and we can plug this into the join geometry. Actually, let's get another join geometry node, and we can connect these two here, and then connect this to the first join geometry node. Now, they are overlapping, so we can change the seed here. As these are the big ones, we can lower the density, and we can increase the scale a little bit. I will also increase the distance to 0.04 to avoid the intersection. Now, if you look at the droplets, they are not very smooth. So we can add Set Shade Smooth node here. And we can also add a Subdivision Surface node. Level 1 is enough. Drops will need separate material, so let's add a Set Material node here at the end. At the moment, we don't have the material to choose from, so we can create one. We can select one of the drops in the collection, and we can create new material and rename it drops or whatever you want. We need to change the color to pure white, roughness to 0, IOR to 1.33, and we need to increase the transmission to 1. And that's it. If we go to render view, we still don't see the material because we need to select it in the geometry nodes. By the way, I'm using Cycles render engine and device set to GPU. I'll also turn on the denoising. We can select the bottle and go back to geometry nodes, and we can select the material. And now we can see it. If we zoom in, we see that the big and small drops are intersecting and it doesn't look good. There are a couple of different ways of solving this. I will add the delete geometry node in this branch where the small drops are and change it from point to instance. Now everything disappeared. That's because we need to specify what we want to delete. For that, we will use proximity to the big drops. First, we need to realize these instances, and then we will use geometry proximity node. And to control what distance we need, we will add less than compare node. And we can plug this into the selection of the delete geometry node. Now everything is back, but if you write 0.01 here, we can see that the small droplets that are less than this distance from the big ones are deleted. We can even use the smaller number. Now we have a small and big droplets, it's time to make the animated ones. But before we do that, let's organize this a little bit. We can frame these and rename them so it's easy to see what's what. Okay, for the animated drops, you could simulate this so they are influenced by force like gravity, but this way it's much harder to control and art direct them. So in my opinion, it's much better to make them with a separate curve object that you can draw as a path wherever you want. For that, we can add a Bezier curve into the scene, and we can go to edit mode, and while everything is selected, we can delete all vertices. We can open a toolbar by pressing T, and we need to select this draw tool here. We need to draw on surface, so we can change here from cursor to surface. And now we can draw a path where we want the animated droplets to be. Now we can select the bottle and go back to geometry nodes. We can drag this Bezier curve into the tree here and change position to relative. As we use the Bezier curve, it doesn't have a lot of points, so first thing we need to do is to resample it. For now, I will use evaluated, but later I might change this back to count. Now we want to make sure that the curve is sticking to the surface of the bottle, so we can add a set position node. And from the bottle geometry, we need geometry proximity node, and we can connect the position into position here. And this will make sure that all the points are sitting on faces of the bottle. Now, first I want to make a mask that will remove the droplets from the path. So I will add a trim curve node. From here, we need the curve to mesh and another geometry proximity node, and we need to change from faces to points. And from distance, we need less than compare node. To make this work, we need to add another delete geometry node just after the join geometry where we have both big and small drops. And this also needs to be set to instance. Now we can connect the result of the compare node to selection here. And it seems like nothing is happening, but if we increase the distance, we can see that the points are being removed where the path is. Okay, now let's make the actual droplets. I'm going to duplicate this trim curve node. Next thing we need is the set curve radius and also curve to mesh node. But for this one, we will use a curve circle as a profile. We can lower the radius and resolution for now. Now, if you plug this into the join geometry, we can see this tube that follows the path. And we want to be able to taper it and control how it looks. And this is where this set curve radius node is used for. For that, we will need the spline parameter node, and we will plug the factor to the float curve. Now with this one, we can control how the curve looks from the start to the end, and we can make the shape that we want. And we will plug this into the radius here. Nothing happened yet. That's because we need to use the radius for the scale here on the curve to mesh node. And now we can see that the curve is taking the shape of the float curve node. And we can increase the radius on the curve circle to control the size. Also, you can check fill caps here. Now if we adjust the end of the trim curve node, it looks like the droplet is moving along the path. And we can use the same value to control the end of the both trim curve nodes. Now the droplets will be removed dynamically as the animated one moves. To control the length of the trails, I will add the math node set to multiply, and we can connect this to the start here. I also want to add a subdivision surface node at the end here just to make this droplet look more smooth. We can also add the set shade smooth node and the set material node, and it looks good now. One thing, if we zoom into the side of the bottle here, we can see that the droplet is going inside, which can cause shading artifacts potentially. To fix this, we can add transform geometry node to this curve circle. I'm gonna change X and Y scale to 0.6 just to squash this droplet a little bit, but you can adjust the Y later if you want more squash. And I will use Y translation to offset the droplet so it's not inside of the bottle. This looks better, but problem here is that now if we animate this, due to the tilt of the curve, you can see the strange rotation and bending of the droplet, which doesn't look good. To fix this, I will add the set curve normal node, and we need to set this to free. And we need to get the normal of the bottle, so I'll duplicate this group input node, and we can sample nearest surface. This needs to be set to vector, and value will be normal. Now we need to cross product this with the curve tangent to get the binormal. And we will need to cross product this again with the curve tangent on top and the cross product on the bottom. And we will plug this into the normal of the set curve normal node. You should probably normalize this as well, but this will work. We got something now, but it's still not perfect, so we need to add a set curve tilt node and use 90 degrees. And it looks good now. Now, to get more of the animated drops, you just need to draw more of the curves in the edit mode of the Bezier curve. One problem with this is that they're all moving in the same time and the same speed, so we can offset this by adding a little bit of randomness. We can add another multiply math node here after the value node, and we will plug the value into the bottom socket. For the top socket, we can add a random value node, and you can experiment with the max and the seed to get the look that you want. If you're getting some glitching, you can try changing the resample curve count and use high number. Now we want to be able to control if we want to have these animated trails or not. So we can add the switch node here at the end and plug this into the true. And we can expose the switch to the outside so we can control it from the modifier tab. We also need to do the same for the delete geometry node, as if there is no trail, there's no reason for the drops to be deleted. And we plug this switch to the same socket in the group input node. Another thing we can expose is the value for the animation. So instead of the value, we can plug this into the input node so we can control it from the outside. We can rename these to know what is what on the outside. And we can do the same for the trails. Now we can control these from the modifier tab. If we select the cap, we can add the new geometry node modifier and select this droplet generator, and now we have droplets on the cap without the animated part. Last thing, we need to capture the attribute for the wetness map where the trails are moving. So we can add the store name attribute node, and it needs to go on this noodle where the main geometry of the bottle is. We can name this wet, and we need to plug this compare node into the value. Now we can go to the shader editor. You can see that the material is very simple, and we need to add the attribute node and write wet here, as this is what we call the attribute. Here after the color ramp, we need to add the color mix node, and we will use the attribute as a factor. And with this B socket, you can control how reflective or opaque the trail is. Optionally, you can add blur attribute node into the geometry nodes just to smooth this out a little bit. And that's it. Now you have your own droplet generator that you can animate as well. Hope this was helpful and you learned something new, and I'll see you in the next video.